All right, we move to something really important, the null space of a matrix. All right, so let's remember that AX equals 0 is called a homogeneous system, right? Homogeneous just means equal to 0. And so what do we know about a solution to this homogeneous? That there's always the trivial one, right? X equals 0 is always the trivial solution. It's always there. So we are interested if there's a non-trivial solution. And if there's a non-trivial solution, which means there's some x, a vector x, maybe it has some zeros in it, but it's not all 0. In order to get a non-trivial solution, there has to be one free variable, at least one free variable. And then when we find the free variable, that means that we can set the solution as a span of the vector, and that a vector will span the solution set. All right, so wait a minute, doesn't that give us a subspace? If I can say a span of a vector, that means I've got a subspace. And so what we do is we call this the place that all the vectors x that go to 0, the null space, or null A. So all the number of vectors in the spanning set is equal to the number of free variables, and we'll see that illustrated. So when we find the vectors in null A, we say that null A is implicitly defined because it takes a lot of work. It takes a lot of work to find null A, to find those free variables, to set up the vectors. When we turn the page, we're going to find something else called the column of A, and that's going to be a lot easier to find. But null A takes quite a bit of steps. So what we want to do is find an explicit definition, which means we're going to be listing the vectors, and when I find that set of vectors, that spanning set, the spanning set is just the set of vectors that spans the solution, these vectors are automatically independent. And that's going to turn out to be important for us. All right, so null A, if I have this matrix A and this vector W is null A, is this vector in null A, which means if I does this vector, right, so remember I have the vector like W would be here in the domain, does AW, right, do the transformation of A, does it go to the 0 vector is the question. Does W go to the 0 vector when I multiply it by A? So here's A, here's W, I multiply it together, I get to the 0 vector. So yes, W is in null A. So null A is in the domain because it's the x's that go to the 0 vector. So this vector W maps to the 0 vector is what we say. All right, so now here's the harder part. This is the work that's necessary. So it's lots of work to go to find null A. So here's my matrix A. So finding null A, finding the vectors that span the solution set. So I did row echelon, so I had to get a 0 here, right? So I got to this, augmented it with zeros, right? Because this is just A, and I'm solving AX equals 0. So I'm finding these x's that will map to the 0 vector. So that's what this is, the zeros here. Okay, so once I get to here, then I take this and I write what it means. So x1 minus 7x3 plus 6x4 equals 0. And this gives me x2 plus 4x3 minus 2x4 equals 0. So solving for my two basic variables, that's x1 and x2. And then I can see that I have 4 variables. So you know you have 4 columns. So that means 4 variables. So let me write that down. 4 columns. So that means I have x1, x2, x3, and x4. So I always have a 1x for every column. So then I take the time to rewrite. So I pull out my 2 free variables. And so the spanning set for null A is this set of vectors. So we just say null A is, and then these parentheses, they kind of imply the span of, and that's our spanning set for null A. All right, so let's go do one on our own. So if you want to turn it off to see if you can get to this one on your own, and then turn off my video and then come back that would be great. Otherwise, I'm just going to dig in and you can follow along. Could be good for your practice. Okay, so this already is in reduced row echelon. So this gives me x1 minus 2x2 plus x4 plus 3x5 equals 0. So there's no 0 here, right? So in my mind, I'm augmenting a with 0. So that I'm solving ax equals 0. So there's no difference putting zeros at the end, so I just imagined it there. All right, so the second row gives me x3 plus 2x4 minus 2x5 equals 0. Okay, so there's two basic variables only. So let's go solve for those. So x1 is 2x2 minus x4 minus 3x5. x3 negative 2x4 plus 2x5. Okay, so since I only have two basic variables, and I can see that there's 5 variables, what do you know how many free variables there must be? So I have to have this many total, so that must mean that there's 3 free variables, right? Because 2 and 3 have to give me 5. Okay. So let's start doing it. So again, I'd always suggest you just take the time to write out x1, x2, x3, x4, x5, just so you don't forget a variable. So x1 is 2x2 minus x4 minus 3x5. x2 is itself. x3 minus 2x4 plus 2x5. x4 is itself, x5 is itself, and there we have it. There it is. Okay, so I'm going to break this up. So I'm going to have x. So anything that's not a basic variable is a free variable, right? So I have 2, 1, 0, 0, 0. So each of these vectors should have 5 entries, right? So x sub 4, negative 1, 0, negative 2, 1, 0. And x5, negative 3, 0, 2, 0, 1. Okay, so how I say the solution is I say null A is equal to, put those little squiggly parentheses, so that means the span of, and I just list these 3 vectors with commas between them. Negative 3, 0, 2, 0, 1, and then I ran out of room to put those squiggly lines at the end there. So that's my spanning set.